Hi guys, you're welcome to today's class. Today we'll be looking at the problems in physics. When I actually started this journey, I intended solving problems in physics, math physics and chemistry. But I didn't really want to club things together by say, okay, solve math problem succeeded by physics and that of chemistry. It may confuse a lot of students. And reason being that most of the topics you find in mathematics, you also see some of them in physics, and some of the ones you see in physics, you find them in chemistry too. So I didn't want any form of confusion. So today we will do physics and see how far we can go before we can actually switch to chemistry, so that I can ensure that we have touched the three parts. So today in physics we'll be looking at the problems in motion. I'm really not going to talk about types of motion and all that. I believe that you are students and you also conversant with them, but we'll really be talking about kind of taking problems and the emotion and solving them, just like we did in mathematics. So for motion, we'll be taking a formula for solving motion, or solution in motion anyway. We have that acceleration a is the function of change in velocity over time. Our time taken, we use small t rather, so that won't be period. And change in velocity, we have the final velocity minus initial velocity over time taken. Just writing them minus u over t. Now, this can also be, change the subject formula, we have v equals to u plus at. We refer this to the equation 1. We also have that velocity is equal distance over time, and distance, yeah, velocity multiplied by time. Or the most of these formulas, if not for these formulas, will always appear one way or other in solving problems in motion. The distance is equal to velocity times time. Now we also have that average velocity. Average velocity here is equals to final velocity minus initial velocity divided by 2. Divided by 2. And distance here is equals to average velocity multiplied by time taken, which can be v plus u over t, sorry, over 2 multiplied by t. Let's refer this to as equation 1b rather. Now, say we substitute equation 1 into 1b. We will have that x, that distance, equals to u plus at plus u divided by 2 multiplied by t. Remember, we are substituting equation 1 into equation 1b. Equation 1 is this. I'm substituting it into equation 1b in this. So from this multiplied by t divided by 2. Now we have that s equals to 2u plus at divided by 2 or multiplied by time taken t. Therefore x here, that distance, equals to 2u plus at divided by 2 multiplied by t. Yeah. Now we'll break them into two. We have 2ut multiplying by this divided by 2 plus at square plus 3 multiplied by this divided by 2. We will then have that x is equals to, this 2 will cancel this 2. We have ut plus at square over 2. Therefore, finally the s equals to ut plus, to remove this division sign, fraction sign, we introduce 1 over 2 at square. We call this equation 2. Now, to get equation 3, we still refer back to equation 1, which is v equals to u plus at. Now we square both sides. Squaring both sides, we have v square equals to u plus at square. Now expanding them, we have v square equals to u plus at and then u plus 80. Now multiplying this through, u square is equals to this u multiplied by u, have u square plus u multiplied by 80, you have u 80 plus this by this, also have u 80 plus a square t square, which is further broken down to be u square plus u80 plus u80, you have 2 aut plus a square t square. Therefore, v square is equals to u square plus 2 into ut plus at square over 2. Now we'll continue. I believe that my students are following. So even if I wipe this to get space, you would understand where we are and probably where we are going to. Now, stop that u was 80. Therefore, we have v square equals to u square plus 2a into ut plus 1 over 2 at square. Now, 280 ut plus half at square is equals to s, which is called distance. I think that was okay. That's equation 2. If you watch this, what we have here is also the same thing as what we have here in equation 2. Therefore, we can say that v square is equals to u square plus 2a. Instead of writing this, we just add x, which is the distance, because this is already a formula for distance. So we just employ distance, and this here forms our equation 3. Now this is gotten. This is the first equation, as I raised it. This is second, and this is the third. Let me just write it in normal equation 3. Now we also have, remember, Motions is both vertical and horizontal. These are mostly for horizontal motion. Now for vertical motion, I'm really not going to solve them as I got these ones anyway. I'll just write them down. For vertical motion, we'll see the comparison. We have that. Okay, let me compare it with what we have with horizontal motion. Horizontal motion here, okay, let me say horizontal and vertical. And this is vertical motion. For horizontal motion, just like we did before, we have a V equals to U plus AT. That's the first equation. The other one has we have X equals to UT plus half AT square. And the other one, last one, is V square equals to U square plus 2AS. Now for vertical motion, we have V equals to U plus G, acceleration due to gravity divided by time taken. This one is a linear acceleration, this one is acceleration due to gravity. For the other one, we have Y, that's distance, equals to UT plus half GT square, still acceleration due to gravity. And the other one, V square equals to U square plus 2G, still acceleration due to gravity by multiplied by distance y, still s because it's a vertical motion. These are the formula with which you can use to solve problems in motion. And I believe by next class I will be solving problem on them on motion, and you will see how the formulas are being applied. Thanks for watching, and look out for more problem solutions in motion. Bye.